Hi, this is Mark Berkey from Berkey Academy, and today I'm going to start a series of videos doing basic descriptive statistics. Descriptive statistics is what you do when you have a lot of numbers and you want to summarize them into a few numbers that help you describe to someone what that data is about. And there are a lot of different characteristics of data that we'll want to explore and things that we'll want to describe in various ways. And in this video, I'm going to cover the mean, median, and the mode. Now, these are three different numerical descriptive statistics that all are getting at a similar idea. The mean, median, and the mode we all call measures of central tendency. So central tendency. Now, what does that mean? Well, central tendency means either what it would be like to be in the middle of these numbers, or what it would be to be a common member of this group of numbers in some way or another. And all of these three measures of central tendency hit at a slightly different aspect of what it would mean to be common or kind of in the middle or something like that. So let's explore these three things so that we can see what the differences are. Now, all of you have probably heard of the mean, median, and the mode, so my goal here will be to give you a few additional insights as we go along, and not just the very basics. Here are some numbers that might form a data set that we're interested in. Let's suppose that, for the sake of context, that these are how many free throws in a row some basketball players could hit. So we sent everyone to the free throw line and we said, start shooting free throws and let's see how many in a row you can get. And so we have 12 numbers here, and we describe that with this little notation, n equals 12. And sometimes people will use capital N, sometimes small n. The only difference between those two would be that sometimes people use a capital N to refer to the total number of people in a population. Sometimes people will be more likely to use a small n when they're talking explicitly about a sample drawn from a larger population. So perhaps this might be all 12 members of a basketball team, in which case we would use capital N equals 12. That would be the preferred way. But if these are 12 people, a sample of 12 from all of the kids at a basketball camp, for example, then we would want to use small n. That more precisely conveys, now this isn't all the kids, this is just a smaller group. And we're using that smaller group to try to learn something about all the kids at the camp, for example. And that distinction becomes important sometimes, as we'll talk about in just a minute. First, let's talk about the mean. So we have these 12 numbers of free throws hit in a row from 12 different kids. What if we wanted to first start off by calculating the mean, or the average? Now the mean, just to be a little more specific and give you a little bit more information, there are a lot of ways to calculate averages out there. The kind of mean that we are going to be talking about in this video, to be more precise, is called the arithmetic mean. Arithmetic mean. I will make a video in the future about more fancy kinds of means that you can do. But when we typically talk about what's my average score, we're talking about the arithmetic mean is the more precise term for that. How do you calculate that? Well, everybody probably has seen this before. To calculate an average, let me write down the formula with what we call summation notation here. The Greek capital letter sigma in statistics we use as a placeholder for add things up. So sigma means add things up. What are we going to add up? Well, we're going to add up, in this case, x's, x with a little subscript I on it. Now what in the world does that mean? What we're saying here, this is shorthand for add up all of the xi's. What's an xi, you might wonder? Well, let me tell you more explicitly here. This number 1 in the data set, we would say, is our first number in our data set, x1. This number would be our second number in our data set, x2. And this would be x3, x4, x5, x6. And so this is saying, take each x from I equals 1 all the way up to n. Take each number and add it. So take x1 plus x2 plus x3 plus x4. Take all those numbers and then divide them, after you add them up, divide them by n. That gives you the average. Now we have two different symbols that you'll commonly see to represent the average. And let me tell you about both of those. One of them we call x with a little line on top or a bar above it. We call that x bar. Is the way you'd read that, x bar. And x bar is the symbol you use for an average that is if we're in this case where we use little n that I told you about before, we call it a sample mean or a sample average. Sample average. And the big deal is we want to tell people that this is not the average of all the things that we're concerned with in the population, that this is an estimate. So x bar explicitly tells people this is an estimate of a larger group. This isn't all the data for the group we're interested in. If you have all the data for the group you're concerned with, say if this is all 12 members of a basketball team and that's all you care about, then we use the Greek letter mu. Mu. Now let me draw that again so you can kind of see how that works. It's like a combination of a cursive M and a cursive U. And I'm probably not very good at doing this, but you see, if you look at it one way, you could see that's a cursive M. If you look at it a different way, you could say, well, maybe that's a cursive U. And that's the Greek letter mu, which is spelled mu. So that's a way to remember. It's like an M and a U, it's mu. And we use that symbol for a population average. This is the real deal. It's not an estimate. It's the average of all the people or all the things that you're concerned with. So population mean or population average. So x bar, estimate, mu, real deal. The truth. It's the same formula. There's no difference between these two formulas really at all. It's just the symbols we use convey whether it's a precise number calculated from all the data or information on all the things in the population, or whether it's just an average of a sample. Is it an estimate, in other words? Now, what does an average mean? Well, most people have seen averages enough to where you kind of have a gut feeling for what it means, but let me give you a picture interpretation of what these numbers are telling us here. So let me graph these numbers so that we can get a picture, and then I'll show you what these numbers mean on the picture. So I'll graph these numbers in purple here. So our first number in our data set was 1, so let me put a dot, 1 dot here. Our second number, so that's a little ugly. Let me erase that and make it a little smaller. Okay. That's still pretty ugly. I give up. Our next number was 2, and we had 3 2s. So what we're going to do is we're going to put 3 dots here. Let me try one last time to do a little bit better job on that 1. Okay, not too bad. So we had 3 2s. We had 2 3s. All right, and then we had a 4 and a 5, 1 4 and 1 5. So on the x-axis here, these are the numbers that I'm putting dots wherever we have a number in our data set, and then I'm going higher as we have more examples of that number. So 3 2s, 1 2 3. And then we had 2 6s, 6 6, and then we had an 11 and a 15. Kind of way out here. We call these outliers because they're very different from the rest of the group there. Now what's an average doing? Well, if you calculate the average of all of these numbers up here, what you're going to get is that the average equals 5. So we could say x bar equals 5 if this was the average of 12 sampled from a larger group, or we'd say that mu, population average, equals 5. Either way, since it's the same formula. But what does that 5 actually mean? Well, if we go back down to our little picture here, it means where this picture would balance. Now, what do I mean? Well, what if we had a piece of wood here on the bottom, and then we were to stack a brick on the wood for each of these numbers at the locations where we see them. So we put one brick here, 1 foot in from the end of the board. 2 feet in from the board, we stack 3 bricks. 3 feet in from the end, we put 2 bricks. 4 feet, we put 1. 5, 1. At 6, we put 2. And we don't put anything 7, 8, or 9, or 10 feet in, but we put 1 brick at 11 and 1 over here at 15. If we were to make that kind of real-world, construction or sculpture, if you want to call it, then what the mean of 5 tells us is that if we were to put a fulcrum, a triangle, right there, then that is where that board would balance. It would perfectly balance right there at the number 5. Now, why would it balance there? Well, because even though there are a lot of bricks just here to the left of 5, they're very close to the pivot point here. These two being much further away, these outliers, tend to have a lot more leverage, right? If you push down on the end of a long lever, you get a lot more power. So these two bricks on the very end have a lot more leverage pushing this down than these do over here. So it would balance at 5. If we tried to balance it at 6, it would tip down to the left. And if we tried to balance it at 4, it would tip to the right. So that's a way to picture or really think about what an average is calculating. Now, just a couple other quick things about an average to know. Our average of 5 is actually a number in the data set, but it doesn't have to be, of course. The average could have been 4.369, and all the data we happen to have here are integers, so that's no problem. It just happened to turn out that the average was exactly 5.0000 this time. But the number doesn't have to be in the data set. It doesn't have to be an integer or anything like that. Now, let's move on to the median. The median is what some people will call, I don't like it when people call it this, but let me start off with this because I'm sure that you have heard this. A lot of times people will describe the median as the middle number. I don't like this because it's a little vague. What do you mean by middle number? The median, the more technical way or precise way to think about the median is we want to find a number so that 50% of the numbers in the data set are larger than that number, and 50% of the numbers in the data set are smaller. So let's go back and look at our numbers so we can find what the median is. Let me clean some of this stuff up there a little bit. So we have 12 numbers. If we want to find the median, where half of the numbers are bigger, half the numbers are smaller, basically what we're saying is we want an even number of numbers, even split between the two. And if there are 12 numbers, an even split would mean there are 6 on the right and 6 on the left. So 1, 2, 3, 4, 5, 6. We want to split our data set right there. 6 numbers on the left, 6 numbers on the right. But the median is a number. We have to find a number that gives us half on the right and half on the left. While technically anything between 3 and 4 would work, 3.1, 3.9 would work, the convention is when you have an even number of items in your data set, like 12 is an even number, that means it'll evenly split with half on the left and half on the right. We average those two middle numbers there, the 3 and the 4. So we average the 3 and the 4. Here the median would be 3.5. 3.5 is a number that splits those into 6 on the left, 6 on the right. Now what if we didn't have an even number of numbers? What do? Well, let me add one more number here to our data set. Suppose we had a 20 there, and that was our new data set, and now instead of 12 we had 13 numbers. How would we find the median? Well, with an odd number of digits, there will be one number in the middle that splits it evenly, the rest of them evenly on each side of it. And so with 13, what we're going to have is 6 on the left, 6 on the right, and one of the numbers right in the middle, and that number is the median. That's why people say the middle number a lot. So here, 1, 2, 3, 4, 5, 6, the 7th number will leave 6 on the left and 6 on the right. 4 would be our median in that case. What if you had 757 numbers? How could you find that middle number? Let me just run through the process real quickly for you, and if you want a rule, sometimes it's easier to see this. In order to find the median, here's kind of the rule. Take the number of numbers for the median and divide them by 2. Now, if you have an even number, let's go back to the even number of digits again. If you had 12 numbers, n divided by 2 would be 6, right? Since that's an integer, what that's going to tell you is what you're going to have to do is average the 6th and the 7th number. The rule says if you divide them by 2 and you get an integer, average the 6th and the 7th. Average that one and the next one. That'll give you your median. What if you take n over 2 and you don't get an integer? If you don't get an integer, you're going to get a number that ends in 0.5. So what if it was 13? So 13 divided by 2 is 6.5. The rule for finding a median, when you have an odd number and you get this half number here, is to go to the next number. Bump it up to the 7th number, and that one is going to be your median. Let's go look at our numbers again. 1, 2, 3, 4, 5, 6, 7. The 7th number is your median. The median would be 4 in the case where you have 13. If you have an even number, when you divide 12 by 2, you get an integer. Average that one, the 3, and the 4. Average those two to get your median, the 3.5. Okay. Let's look at our little dot plot again down here, our little graph, and let's see where our median is going to be. Our median at 3.5, when we had these 12 numbers, median equals 3.5. Visually, what should we expect of a median? Well, the same thing as when we calculate it, basically. What you're looking for in a plot like this is, are there 6 numbers on the left and 6 numbers on the right? It doesn't matter where those numbers are. All that matters is that there is 6 to the left of 3.5 and 6 to the right of 3.5. Which brings up one more idea that I need to share with you about the difference between the mean and the median. And that is the idea of whether a type of descriptive statistic, like a mean, median, or a mode, is it robust? Is it robust? Robust is just a fancy way of saying strong. A type of measurement is strong or robust if having a few outliers doesn't affect it very much. Let's compare the mean and the median on this kind of idea of robust. As we see, the median here is 3.5. That is where half are lower and half are higher. But the mean here is at 5. the mean is a lot higher. Why is the mean higher? Well, remember the idea that the mean is where this thing balances. And the reason why this balances at 5 are these two guys way out here, these two outliers. These two numbers pull the mean up, but they don't pull the median up. Let's take an even more extreme case. What if we were to move those two, the 11 and the 15, and now they were both 20s in our data set? Think about what will happen to the mean. Well, that's going to pull the average up, maybe to 6 or 7. What's going to happen to the median if we were to move these points to the right? Nothing happens to the median. There's still going to be 6 dots to the left of 3.5 and 6 dots to the right of 3.5. The median will not change. That means it's strong. That means it's robust. A few weird numbers, a few outliers, do not affect it. So that's what we mean whenever we say that measuring something in a particular way is robust. So this is one reason why we prefer the median sometimes. It's robust to outliers. The mean is sensitive to outliers. So sensitive to outliers is the opposite of robust. Now, finally, let's look at this idea of the mode. Now, the mode is just the most common number. So the mode is the most frequently occurring, or the most common. Now, if we look at our data set up here, we can see, let me erase some of these marks here so it's easier to see. Let's go back to our original data set. We have 1, 2, 2, 2, 3, 3, 4, 5, 6, 6, 11, 15. The mode is going to be 2. Because there are 3 2's and there aren't 3 of any other number here. And so our mode will be 2. And again, we don't have a special symbol for the median or the mode. We just say the mode equals 2. It's the most common number in our data set. When you're looking at a plot like this, all you're looking at is where's the highest stack of numbers, right? Where's the highest peak of numbers there? Well, it's right at the 2. That tells you the most common one. So that's the mode. Nothing really complicated here, but let's just go back and think about this idea that the mean, median, and the mode are all measuring some kind of characteristic. The technical term is a measure of central tendency, and something about being in the middle or being common or being normal. What is that for this data set? So the average, again, it's going to be a number somewhere toward the middle of the data set, but it's going to be weighted. It's going to be balanced based on where these individual points are. The median is more specifically the middle of the data set, where 50% of the numbers will be higher, 50% will be lower. The mode more gets into the idea of what's common. And so 2's are common, but it's not really very close to what I'd call the middle of the data set. So it's just a different way of thinking about these ideas. Now, to wrap up, let me mention one last idea about the mode here. This is kind of a common idea that comes up in practice when you're looking at data. Suppose in our data set we added one more number here. Someone else shot 6 free throws in a row. And somebody asked you, what is the mode? What should you answer in this case where there are 3 2's and 3 6's? I see several common responses in this case. The first answer that I don't like very much is, well, there is none. If the mode is the most frequently occurring number, there is no one number that occurs most frequently. So, no mode. I don't like that answer. Here's another answer that you see sometimes that I don't like. I don't like it even worse than the first one. This is what Excel does. If you ask Microsoft Excel, and there are a couple other statistics packages that have this behavior as well, If you ask Microsoft Excel, what's the mode? There's a function called equals mode. What Excel does is will randomly pick one of the two. So random, it could give you 2 or it could give you 6. Since there's 2 modes. And this is the same thing as if there are 3 modes or 4 modes or 10 modes. It will randomly pick one of those. That's pretty bad. It doesn't give you very much information about your data when you just randomly pick one of those numbers. So I don't like that answer at all either. I think the best answer to use in a case like this would be to say there are 2 modes and to tell people what they are. 2 and 6. Now, when you discuss something that has 2 modes, there are a few common terms people would use. Bimodal, bi meaning 2. You'd say this data is bimodal. There are 2 modes. You could also, if the data had 3 modes, you could use the word trimodal. Anything above 3 modes, you would just say is multimodal. Multimodal. And this is a very common thing that happens, and so we have a word to describe it. So this is Berkey Academy signing off. If you have any questions, please leave them in the comment or question section below, and I'll be happy to try to get back to you. Good luck.